All right, so let's go ahead and take a look at this next one. So a couple things going on here. We're not dealing with hydrogen anymore, and in fact, we have an atom with a lot of protons in it, so big number for Z. And because of that, we're expecting a very large energy. So keV is kilo electron volts. So we have to remember that we're getting eV electron volts by default, and we'll have to convert. So we can throw that work in. Um, Technically, our original setup, like the way we start, is we're still kind of sort of looking at E4 minus E2, but we don't know these numbers when Z is 67. Technically, you can use it for hydrogen and scale it, but I'm going to show you how we can do this all at once. So we've got negative 13.6 electron volts, just like we've had. And then, on the one question, I put 1 squared for Z, and didn't do it anymore because that was fairly pointless. But now that we have a non-1 number, then 67 squared is actually going to change this by quite a bit. Then using those fractions, 1 over 4 squared, so don't forget these still get raised to exponents, minus 1 over 2 squared. And then we can see we've got electron volts from this, so technically we can stick all of that over 1. And then electron volts go down here, and kilo electron volts, keV, is what we're trying to get to up here. All right, so 1 kilo electron volts, kind of like kilograms or kilometers, right? So kilo or K means 1,000. We've got 1,000 down here. So whatever answer we get from the blue part, ultimately we divide it by 1,000 so that it scales down and gives us keV. All right, so don't forget all of these different parts that are going to be squared. So when you run this through, you might want to do, negative 13.6 times 67 times 67 to get a number. Then you may want to work out these fractions and get that negative number and multiply, divide by 1,000. Bit of calculator work here, but I'm confident that you can get it done. And overall, 11.45 kilo electron volts.